Good morning, everyone. You're an Islander EI, and welcome to Biometric Authentication Under Threat, Liveness Detection Hacking with HC Ma. Stop by the business hall today, located in Mandalay Bay, Oceanside and Shoreline Ballrooms in Level 2, during the day and at 5:30 tonight for the welcome reception. That's also the location of the Black Hat Arsenal, and if you would,
Okay, thank you guys. Today I'm gonna talk about how to do the biometric authentication attack. So before we get started, and I have to introduce my team. And who are we? We are from Tencent, the biggest social media and entertainment company in China, and we're from the Tencent Security Shen Lab. And we do a lot of applied and real-world security research, especially the cutting-edge technology. And last year, we presented a new vulnerability of in-display fingerprint sensors. And actually, this research was done by mostly by the Chen and Ma, and I'm not actually involved in this project too much, and because they don't have the visa to come here, so I have to present this talk instead of them. So and all your applause and honors belongs to them. So okay, here is the outline of my talk. And roughly my talk divided to two parts. And the first part is how we do the signal injection to bypass the Liveness detection. And the second part is about how we exploit the insecure recognition sense and to bypass the attention detection. So before I go in deeper to my talk, I have to clarify some basic background of my talk. And the first is, what is biometric authentication? So biometric authentication is the device use some sensors to collect your information, like your face and the voice and the fingerprint and the iris and also the palm print, and use that to feature matching and to see if you are the person that's authorized. So and it contains a lot of application of area, and you can use this kind of authentication to unlock your phone and to recover your password, and also you can use to log in the apps. And in China, we use this for a real name authentication. So in the bottom, you can see is the typical progress and how the biometric authentication works. And the first is trying to collect the information and do some pre-processing to turn the collection into some machine recognized data stream or some kind of data, and then the sensor will try to do the liveness detection. After the liveness detection passed, and it will try to the fetch matching and to see if you are the person. So what is liveness detection? And liveness detection is trying to identify if you are a live person and not the forged entity that you are trying to unlock the phone, or you use the biometric authentication. So there are a lot of methods to do this kind of detection. So like the sensor can just distinguish the texture and to see if the texture is like a human skin or not like a photo or something like. And they can also to do the optical flow and to see if it's a skin. And another also there are a lot of interactive action check, and there will be some command and displaying on the screen, and or for you to nod or shake hand or open mouse and to see if you are live person. And also in iPhone or some other smartphones, it will be some specific hardware to do this liveness detection. And the third concept I have to emphasize is the Face ID attention detection. So attention detection is kind of to check if you are look at the camera when you're trying to use your phone to unlock use your face to unlock your phone. So defaultly, this attention detection is enabled, and whenever you want to disable it, it will be alert shown at the right. So with this detection was enabled, so there is a stupid way to trying to bypass this attack this attention detection. So absolutely, my talk will not cover this kind of way to bypass this, and I will introduce an ultra low cost way to do it. So we come to summarize the previous studies on this area, and mostly they mainly focused on to generate the fake video and or audio to bypass the to do the attack, but they are not very few research and focus on how to bypass the liveness detection, because the liveness detection is crucial. You have to bypass it, and then you can use your stuff to bypass the authentication. And also there are some research on how to bypass the Face ID with the 3D marks, and but that require a lot of information, and it was proved to it's not easy to reproduce. So our research is mainly focused on how we bypass the liveness detection. So here we go to the first part and how we do the signal injection. And before, let's just go back to see what's the difference between when you do the biometric authentication with real information and fake information. If when you use face for the biometric authentication, and the fake one will lost some HSL space color, and because you are trying to use some video or use some photos, and that's some colors will be lost when the camera capture that things. And there will also some focus blurred, and the texture is also is not the same or not the similar, and the optical flow is obviously is not is another important way to detect is the difference. And some kind of sensor will trying to do some frequency response and to see if the material you are trying to attack to unlock the phone is if the same or similar to the human skins or human organs. And so another element when you're trying to unlock the phone with your voice, and there are also some difference. So the first is some playback reverberation object, and also the background noise is not the same. So how about inject the signal directly? And So with the if you we think about how to inject the signal, and that we can avoid any information lost when do the secondary when you do the secondary accretion, and we can also have the attack medium characteristics, so you can just control it by your software, and it's if we do it in the hardware level, and it's not detected by some the higher software. So here is the requirement how if we want to do the injection, we want the low latency because we want the system act like the native just as little delay as possible, to just like a native camera. And we can also we need good capabilities, and to make it suit for most situation. And we want the fake data can be generated and imported in the real time. And we can and the fourth is we want this transparent and cannot be detected by any emulator or undercode software technology. And so here is our scheme, as you can see, and at the bottom is just a schematic of our solution, and we used a module to convert the HDMI signal to the CSI signal, because the most mobile device use the CSI socket to connect their camera, and we use that module to convert to the HDMI signal and then connect to our PC, and that make us the camera can be simulated as the output of your PC. So you can just to do all the things in your PC and generate and play it all the audio, video, and in your PC. So and then we hook up another line. Debug line to monitor the interactive action, and to see if we can just generate the corresponding video according to the command. And here is just the real picture, and the left is the schematic, and the right is the whole setup. And we come to the demo. Okay, so we use just a photo to generate the animation with some software, and we use script to make it work. It's blinking, and it's not, and it's just turn around, and then we just connect it to our developed kit, and outputs the signal to the developed kit, and that is make it act as a camera in the developed kit. Just a minute. And it's just like a camera. So then we can manipulating the video in the PC, and just like the native camera is capturing the image. So okay, and another part is we're doing the audio injection, and that is quite the same. We use another module to convert audio to a Mac, and then we connect this. The voice they want us to speak out, and the test or the random number. So here is the whole setup. We just proposed two versions, and for Android and the iOS device. So you might think this kind of attack is useless because you cannot open up the victim device and you cannot just hook up your device into its CSI cable and inject your signal. But what if our target is some kind of app login with a biometric signal? So what about we spoof it? And we can spoof what our ideas is come from this talk is also by my colleague, and what we want to do is trying to spoof the whole device. And we do when we do this research, and we found if the biometric authentication for an app is not default enabled on a dual device, but if we forge and the server trying to collect the local device fingerprint and upload it, and then they stored and bind all this information to your account, and after that, and they can enable it. So if we can steal all this device information, and we can forge this device, and then we can enable it in our controlled system. And so the general steps to do this device fingerprint spoofing is the first we reverse engineering the algorithm and how they collect this kind of information, and then we steal the information from any technique, and because you can as you can see, then some kind of information can be stealed without touching the victim's device. So after that, we inject all the information to our control system, and then we enable these things. So here we come to our new threat mode to combine these two kind of technology. And the first is we're trying to do device fingerprint spoofing, and then we collect some victim's password and voice recording, and then we generate fake video and audio materials depend on all the material we collected, and then we do the hardware injection. Then we can log into the app or the device, and then we can just recover their password and we hack it. So the second part is how we do explore the insecure recognition things. So why does this kind of thing exist? Because when the vendor develop I mentioned is Apple, and when it's trying to design their biometric authentication, they have to consider some special situation and like the light situation and the environment, and when you're wearing glasses, and also is noise and accent. So they have to consider this kind of special situation. So when they trying to apply their authentication to this special situation, and that means they have to balance the user experience and the security. So not all the security check will be used. So the attacker can utilize these kind of things and to just get the detection to the attacker controlled scenario and to do some attack. So let's come to how we bypass the detection of Face ID. And the challenge is we don't want to wake up when the victim is sleeping, we don't want to wake up them. And also the 3D eye, the technology and the information cannot be easy to forge. And also we don't want to huge high cost and So how we can do? We don't want to do this bypass like the GIF video that. So how we can do? So after we do some research, we found some weak points, and that the Face ID allows user to unlock the phone when they wearing glasses. But in this situation, they won't. If you are wearing glasses, they won't extract the 3D information, and they're trying to match the 2D's characteristics instead of 3D's. So that's the clue one. And in this case, we can get the algorithm trying to match the 2D eyes. And the second fact is if the victim or if the user in the dark environment and we do a serious experiment and we found if we can just abstract our eyes to just like a black area and a white point on it, that's just a 2D eyes abstraction. So that's the second clue. And the third clue is, so what is, when you're trying to do the attention detect, so what's the abstraction of that? It's really simple. It's just a white point in the middle of the black area. So combine all these clues, we develop our device. And the simple device, we use it to bypass all the attention detection. It's really simple, just ordinary glasses with two kind of tapes. One is black and the other is white. So it's ultra low cost and with high success rate. And it's really practical, and you can just make it in just 2 minutes. So here is, we come to the demo, and here is just the situation we test, and we enable the attention of Face ID, and so we come to video. Sorry. So here's the victim, he's sleeping, and his phone is on the table, and we're trying to unlock it, and it's not successful because the attention detection is enabled. And after that, and you can see some things on the table. One is our X glasses, and the others all the material we make these glasses. And we're trying to wear these glass to the victim, and yeah, hopefully he won't wake up. And you can see he's still sleeping, and we're trying to unlock the phone again. And as you can see, the phone is unlocked. Okay, so what about the mitigation of all the vulnerability we found? And the first is how to avoid the hardware layer injection. So first we propose is it's better to use the trusted camera to collect the face information, and that's cannot be forged easily, and forbidden to not accept any voice from the microphone cable, and that's just avoid the audio injection, and then you can try to increase the weight synthesis detection and trying to the last one is you better to use some device binding mechanism to detect the spoofing. So the mitigation for the X glasses attack is really simple. You can just detect the texture and also the deep information of an eye at eye area, and to see if the eye is real. So we come to the conclusion, and we propose universal methodologies how we bypass the liveness detection, and we use the hardware level signal injection, and we also create some just reverse the algorithm of attention detection, and to see we found the weak point. And we also propose a new threat mode and to how to bypass the whole secure system, and with injection and the device fingerprint spoofing. And yeah, that's it. Thank you.